Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. So today we will be talking about aggregate properties. आवाज सबको आ रही है बेटा?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Lecture outlines are
Yes,
introduction to aggregates, classification of aggregates, factors contributing to aggregate characteristics, characteristics of aggregates, and finally the tests on aggregate. That which type of test we can perform on the aggregates. So the definition of aggregates. Aggregates is a type of construction material which is used in civil engineering structures or in civil engineering projects. It includes sand, gravel, crushed stones, etc. So I hope you will remember this. The definition of aggregate is the construction material which is used in civil engineering projects, and it includes sand, gravels, crushed stones, etc. Aggregates are the inert materials. I hope you remember what is meant by inert materials.
Reaction नहीं करता.
Yeah, those materials which are not taking part in the hydration reaction. Mixed with binding materials. Now the binding materials normally we are used as cement and lime in the preparation of mortar or concrete and asphalt, etc. In building construction, aggregates are used in the preparation of concrete. Aggregates occupy at least 3/4 of the volume of concrete. If you remember, I told you that 75% of the volume of the concrete is occupied by the aggregates. Aggregate is cheaper than cement, and it is therefore economical to put into the mix as much of aggregates and as little of cement as possible. So being a civil engineer, being a material engineer, you will have to try to make the concrete economical. And how you can make the concrete economical? By using the maximum possible quantity of aggregates in the concrete and the minimum possible quantity of cement. Economy is not the only reason for using aggregates. Aggregates give a higher volumetric stability and better durability to the concrete. So we are always talking about economy. So economy is not the only point that we should use maximum quantity of aggregates. If you remember from the creep topic and from the dry shrinkage topic, we discussed that aggregates are giving the higher volumetric stability and better durability to the concrete. Cement paste alone has no such higher volumetric stability, higher strength and durability. I hope you remember from that lecture. Now, what are the sources of aggregates? From here we can get the aggregates. So we can get the aggregates from crushed stones, that is crushed rock, natural sand and gravel deposits, blast furnace slag, artificial and processed materials, and pulverized concrete and asphalt, or the recycled concrete and asphalt. Here you can see the aggregate sources. This is sand quarry. Maybe you people have seen this. These are natural resources or natural sources. From here you can get the sand. This is the stone quarry from the rocks, and then we have this crush machine. You can pass these stones from this crusher machine, and finally you can have these crushed stones. Normally in some of the places you can have these gravels which are readily available, and you can use this directly in the concrete, or sometimes you need only minor processing or very small treatment with this gravels, and then you can use this in the concrete. Here you can see this what we can say to this material. जी बेटा.
सर ये क्रश स्टोन और ग्रेवल में से कौन सा बेहतर होगा?
Crushed stones बेटा. Those materials which have angular surfaces and angular shapes, they can make better bond, then they can give you better strength. जी, any other question? Arif Wazir?
Yes, sir.
What is this?
सर जी ये तो कोर्स एग्रीगेट है, फाइन एग्रीगेट है, लेकिन नाम पता नहीं की है.
सर ये खाक है वो स्टोन को क्रश करने के बाद जो निकलता है साथ.
सर ये जो डिफरेंट सीफ एनालिसिस से हमारे पास ग्रेडिंग्स करके हमारे पास ये आए हैं.
जी बेटा दोबारा बताएं.
सर ये जो हम ग्रेडिंग करते हैं सीफ एनालिसिस से, उससे हमारे पास फाइनल कोर्स
from the grading you can see over here, this is the coarser, the maximum particle size, followed by the intermediate, smaller, and the finer and the finest. Okay, so this is actually, you can say, the gradation of the aggregates or the well-graded material which have all size particles. When you have such type of materials, then there will be less voids in the concrete and less void in the aggregates. So for that you will need less cement paste and less quantity of water as well. So this is just given for your information and for your knowledge and for your education, that this is the sample of material which shows well graded aggregates. Is it okay?
Yes, sir.
What are the functions
Yes,
of
sir.
aggregates? What are the functions of aggregates? I hope you remember this. Aggregates have the following main functions in concrete. Number one, to provide a mass of particles which are suitable to resist the action of applied loads and show better durability than cement paste alone. So when you are using these aggregates, it will make a proper mass of the concrete or a proper mass of the mortar or a proper mass of the asphalt. And when you are applying the loads on this concrete, it will resist that load properly and easily, and it will be durable as compared to the cement paste alone which you are using. Number two, to provide a relatively cheap filler for the cementing material. So as I told you, economy is the main reason. So to make the concrete economical and suitable for your project. Number three, to reduce the volume changes resulting from setting and hardening process and from moisture changes during drying process or from our in creep process. If you remember from the drying shrinkage, I told you if we use maximum quantity of aggregates, we can reduce the shrinkage in the concrete. Do you remember that, beta?
Yes, sir.
Yes, sir.
Yes, sir.
याद है बेटा सबको? The properties of concrete are affected by the characteristics of the aggregates. So let's talk about the characteristics of the aggregates. The mineral character of aggregates affects the strength, durability, elasticity of the concrete. The type of rock, the mineral characteristics from where you have got these aggregates, it will affect the strength of the concrete, durability of the concrete, and elasticity of the concrete. The surface characteristics of aggregates affect the workability of fresh mass and the bond between the aggregates. If you remember from the smooth aggregates and rough aggregates, and cement paste and hardened concrete. If it is rough, workability decreases and the bond strength increases. The third is the grading of the aggregates affects the workability, the density, and finally the economy of the concrete. Higher aggregate amount per unit volume of concrete results in number one, and less volume changes during setting and hardening or moisture changes increase in volumetric stability. If you are using the higher aggregate amount per unit volume of the concrete, what it will give you, it will increase the volumetric stability of the concrete. It will increase the strength and durability of the concrete, and it will also decrease the cost of the concrete because you are using the maximum quantity of the aggregates, and the aggregates are cheaper than cement. It is a common practice to use as much of the aggregates as possible in the concrete. According to the source, we have different type of sources of concrete, of aggregates. So read this slide. Please read the slide and help me in explaining this. Arif Wazir and everyone. Shabash.
Yes, sir. ये तो natural aggregate और artificial aggregate.
Yeah.
Natural aggregate
जी जी.
सर नेचुरल एग्रीगेट तो कमली जो अवेलेबल होते हैं सर जी, ये शिंगल और ग्रेवल क्रस्टोन वगैरह. आर्टिफिशियल एग्रीगेट जो बाई प्रोडक्ट हम किसी में पेशिंग प्रोसेस से देते हैं, ब्लास्ट फर्नेस
But
से.
natural aggregates consist of rock fragments or rock particles that are used in their natural state, or ORR, are used after mechanical processing, such as you are passing it from crush machine, and then if it has some clay on its top or dust, then you can wash it and then you can convert into the required size, and then you can use it. Some natural aggregates deposits are called pattern gravel. What is pattern gravel? It consists of gravel and sand that can be readily used in concrete after minimal processing. As I told you, if you remember this picture, this one, so these are readily available. You are not supposed to pass it from the crusher machine, and such type of materials are available in this natural nalas on river sides. So you can just have to convert into smaller size, or sometimes you just have to wash it, or sometimes you have just uh, to collect the bigger size particles from it and then use the remaining one. What are artificial aggregates? Artificial aggregates are obtained either as a byproduct or by a special manufacturing process, such as heating. You can bloat the aggregates. You can do you know bloating up aggregates? Anyone in the class, what is bloating? जी आरिफ वजीर, what is bloating?
नो सर, इसका तो पता है।
ये पश्तो में कहते हैं ना औरतवल, इसको उर्दू में क्या बोलते हैं? रोस्ट करना। जी, एनीवन इन द क्लास? जी बेटा, नो? जी, मुजम्मिल खान, मोहम्मद सुहेब, मोहम्मद मूसा।
Yes, sir.
जी, क्या होता है bloating of aggregate? It is actually the heating of aggregates at a very high temperature, and when you are bloating the aggregates, its mass decreases and it become lightweight aggregate. ठीक है बेटा, इसको याद रखो. Blast furnace lake, expanded perlite, expanded clay and shell. These are the types of artificial aggregates. Okay, these are the types of artificial aggregates. You have just to remember it. Now, according to petrological characteristics, do you remember the types of rocks from first semester?
Yes, sir.
Yes, sir.
How many types of rocks we have normally?
3, sir.
3, sir.
3 types.
कौन कौन से होते हैं?
Sir,
Sir,
sedimentary,
sedimentary,
metamorphic,
igneous,
igneous.
metamorphic.
Okay, Arif Wazir, give chance to Ruqayya. Okay, Ruqayya, आप बताइए sedimentary क्या होता है?
सर सेडिमेंट्री जो हमारे पास सर ये छोटे छोटे शेल्स और उनसे बने होते हैं, कंकरियों से और इस तरह से.
Okay, इमादुल्लाह, आप नेक्स्ट बताएं. दूसरा किस्म
सर
कौन?
लेग्नियस रॉक्स।
igneous rock कौन से होते हैं बेटा?
सर जब वो लावा निकल आते हैं सर, फिर वो हॉट होते हैं तो इससे
ओके, मोहम्मद
वो
मूसा,
रॉक बनती है।
कल टाइप आप बताएं. मोहम्मद मूसा. मोहम्मद मूसा, आर यू इन द क्लास? मोहम्मद सोहेब बेटा, आप बताएं.
यस।
जब यस सर कहते हो तो बताया करो ना, कौन सा थर्ड टाइप कौन सा है बेटा?
मेटामॉर्फिक रॉक है सर।
ओके, मेटामॉर्फिक रॉक. मेटामॉर्फिक रॉक कौन सा रॉक होता है?
भूल गए
सर ऐसे रॉक जिसमें सर लेयर्स हो सर, स्लेट्स टाइप।
सर मेटामॉर्फिक कौन होता है जो अर्थ के अंदर बनता है, अर्थ के मुख्तलिफ रिएक्शन हीट की वजह से या प्रेशर की वजह से.
Okay, good. So you remember this. I was just checking you people that whether you remember this or no. Okay, so sedimentary rocks are formed from particles of sand, shale, and pebble, small particles and other fragments, other particles of material. Together, all these particles are called sediment. When these particles are present together, that is sand, shale, pebbles, and other fragments of material, so we are calling it sediments. Gradually, the sediments accumulate. ये जमा हो जाते हैं in layers and over a long period of time hardens into rock. It converts into rock. Generally, sedimentary rock is fairly soft and may break apart or crumble easily. You can often see sand, pebbles, or stones. You can see over here sand, stones, pebbles in the rock, and it is usually the only type that contains fossils as well. If you remember, I told you example of this rock type include conglomerate and limestone. Now, what is petrological or what is petrology? The branch of geology that studies rock is called petrology or petrological. The metamorphic rock. Metamorphic rocks are formed under the surface of the earth from the metamorphosis, that is the change process, that occurs due to intense heat and pressure, that is squeezing of the material inside the ground. The rocks that result from these processes often have ribbon-like layers and may have shiny crystals as well, formed by mineral growing slowly over time on their surface. Example of this rock type are include slate and marble. The next one is igneous rocks. Igneous rocks are formed when magma, that is the molten rock deep within the earth, cools and hardens. Sometimes the magma cools inside the earth, and other times it erupts onto the surface from volcanoes. In this case, it is called lava. When lava cools very quickly, no crystals are formed and the rock looks shiny and glass-like. Sometimes gas bubbles are also trapped in the rock during the cooling process, leaving tiny holes and spaces inside the rock. Example of this rock type include basalt. Here you can see we have this sedimentary rock, we have this metamorphic rock, and then we have this igneous rock. So according to the unit weight, how we can classify the aggregates? Everybody, I hope everybody remember the unit weight. Unit weight क्या होता है बेटा?
Weight per unit volume.
Weight per unit volume. किसने कहा ये?
सर मैंने मोहम्मद जीशान.
मोहम्मद जीशान. Okay. Anyone else? आरिफ वजीर. ठीक कहा इसने?
Yes sir, weight per volume.
Weight of a unit volume.
आप भी कहते कि इसने ठीक कहा है. रुकैया असद.
Yes, sir.
ठीक है इसने. Ahmadullah, what are you saying about this? Ahmadullah, are you in the class? Ahmadullah. Fahad Tayyib. Fahad Tayyib, what is density?
Yes, sir.
What is density?
Mass per unit volume.
Then what is unit weight? Ji. Hamad Khan Muhammad. Hamad Khan, are you in the class? Hassan Akhtar. Hassan Akhtar.
Yes, sir.
What is specific gravity?
Sir, नहीं है sir.
Okay. Haris Abdullah.
Yes, sir.
Haris Abdullah.
Yes, sir.
What
May
is specific gravity?
specific gravity, sir, dimensionless quantity, sir, or ratio of the density of a substance to density of water at specified temperature, sir.
Okay, good. Well done. Okay, so let's talk about the classification of aggregates according to unit weight. How we can classify the aggregates according to its unit weight? So we have heavy weight aggregate, we have light weight aggregate, and we have normal weight aggregates. There are three types of aggregates. We can classify the aggregates into three types according to its unit weight. So the first one is the heavy weight aggregate. The aggregates having the bulk density, that is the weight per unit volume. That is, bulk means the total weight per unit, the total weight divided by the total volume, in which we have the volume of the wires, the volume of the pores, and the volume of the solids as well. That is called bulk density. Is more than 2080 kilogram per cubic meter. At the bulk density of the aggregates is more than 2080 kilogram per cubic meter are called heavyweight aggregates. याद रहेगा बेटा? You have to remember this figure. You have to remember this. Heavyweight aggregates include hematite, magnetite, barite, limonite, etc. Normally we are using this barite for radiation as well. So now these aggregates, they are used as heavyweight aggregates, and they can reduce or they can mitigate the radiation effect in hospitals and some other nuclear power plants. The specific gravity of these aggregates is greater than 2.8. Those aggregates with high density and is used primarily in the manufacturing of heavyweight concrete for the protection against nuclear radiation and as a bomb shelter. As I told you, it can resist the waves or the pressure waves or the radiation as well. Radiation shields protect the operating personnel against the biological hazards in the nuclear energy industry or X-ray, gamma ray at therapy centers. Tendency of aggregate to segregate in a concrete mixtures increases with the density of the aggregate. As the density of aggregate increases, segregation also increases. How? Anyone in the class who can explain this?
सर उसका वेट वगैरह ज्यादा हो जाता है तो सर वो बॉटम पे चले जाते हैं सर एग्रीगेट को
Exactly. उनकी
सीमेंट वगैरह
सेटलमेंट
से ऊपर आते हैं
उनकी सेटलमेंट जल्दी हो जाती है as compared to other aggregates, so it causing segregation. Good. Okay, the next one, the lightweight aggregates. Which one? The lightweight aggregates. The lightweight of the aggregate is due to the cellular or highly porous microstructure of the aggregates. Natural lightweight aggregates are made by crushing igneous volcanic rocks such as pumice, etc. So this can be used as lightweight aggregates as well. Muzammil Khan, Muzammil from Baluchistan, Quetta. Muzammil, are you in the class, Muzammil? No? Okay. So you have some problem with your mic? It is available in Baluchistan in large quantities. It is available, but the transportation charges are very high when you are shifting it to KPK or Punjab, but it can be easily transported to Karachi and the nearby area. But to the power plant area, it becomes costly. But it is available in Baluchistan in high quantity. Synthetic lightweight aggregates are manufactured by thermal treatment of a variety of materials. For instance, clays, shale, slate, diatomite, perlite. बेटा इसकी जो स्पेलिंग है इसको आप फिर देख लीजिए, ए इसमें नहीं है, PERLIT. This is by mistake. Vermiculite, blast furnace flakes, and fly ash. These can be used as synthetic aggregates, and these can be used as lightweight aggregates as well. Density ranges from वहाँ पे कितना था याद है किसी को?
Yes sir.
2080 और यहाँ पे है 1350 to 1850 kilogram per cubic meter. Expanded perlite, burn clays, and its specific gravity is less than 2.4. वहाँ पे कितना था?
Greater than 2.8.
Good. So the next one कौन सा होगा? इसके बाद कौन सा टाइप होगा?
According to density
हो गया, लाइट वेट हो गया, इसके बाद क्या होगा?
मीडियम वेट होगा
जी,
मॉडरेट हो सकता है वो
normal, that is called normal weight aggregate. So the normal weight aggregates are those aggregates which have the normal weight. Gravel, sand, and crust stones, the specific gravity is in between 2.4 and 2.8. Is called normal weight aggregates. Produce normal weight concrete. Produce normal weight concrete having density of 2,200 to 2,400 kilogram per cubic meter. Most common aggregates are sand, gravel, crushed stones, etc. याद रहेगा बेटा ये?
Yes sir. इसमें सर shingle आता है सर, shingle
इसमें मुख्तलिफ किस्में आती है बेटा. अगर if it is in this range, then you can call normal weight. If it goes in this range, if it comes in this range, then you can call heavy weight. If it is coming in this range, then you can call light weight. Okay, anyone in the class who can tell me, if we are using heavyweight aggregates in the concrete, then what are we calling that type of concrete? उसका नाम क्या होगा concrete का? अगर हम heavyweight aggregate इस्तेमाल करते हैं concrete में, तो उसका नाम क्या होगा? उस concrete को हम क्या बोलेंगे बेटा? यार बहुत सिंपल है.
सर हैवी वेट कंक्रीट।
या हेवी वेट कंक्रीट, ठीक है। और इसको क्या बोलेंगे अगर ये एग्रीगेट हम इस्तेमाल करेंगे?
लाइट वेट
लाइट वेट कंक्रीट। एंड व्हाट अबाउट दिस वन?
नॉर्मल वेट कंक्रीट।
Normal weight concrete.
नॉर्मल कंक्रीट।
Good, well done. Okay, if you have any questions so far, you can ask. After that, we can go to the next.
सर सर ये जो
Yes.
लाइट वेट कंक्रीट है सर, आई थिंक ये बहुत एक्सपेंसिव है, तो सर हम इसको मतलब कौन से प्रोजेक्ट में यूज करना चाहिए?
Normally, हर जगह पे ये costly नहीं होता है. It is not costly everywhere. If you have this fume, as I told you, it is available in Balochistan. So if it is available in Balochistan, you can easily use it over there, and it will be not costly. Okay, so where we need this बेटा, जहाँ पे हमने हाई राइज स्ट्रक्चर्स बनाने हो और हम कोशिश करते हैं कि इसका जो फाउंडेशन पे इसका जो वजन आ रहा है, जो 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 डाउन डाउन जो वो है स्टोरीज है, बॉटम में जो स्टोरीज आ रहे हैं, उस पे बोझ कम आए, उस पे लोड कम आए, और उसकी जो डिज़ाइन स्ट्रेंथ है वो हम कम से कम रखें, उसमें हमारा स्टील का खर्चा, हमारे कंक्रीट का खर्चा कम से कम हो, तो इसमें फिर हम हाई राइज स्ट्रक्चर में इसको यूज़ कर सकते हैं। इसके अलावा मैंने आपको बताया था कि जो जब अर्थक्वेक आता है तो इसका जो फोर्स होता है अर्थक्वेक का, इट इज़ डायरेक्टली प्रोपोर्शनल टू द वेट ऑफ द स्ट्रक्चर। अगर वेट ऑफ द स्ट्रक्चर ज़्यादा होगा तो अर्थक्वेक फोर्स ये ज़्यादा अट्रैक्ट करेगा, और इससे जो डैमेजेस होंगे, क्रैक्स होंगे स्ट्रक्चर में, वो ज़्यादा होंगे। तो इफ़ यू आर यूजिंग लाइट वेट मटेरियल और लाइट वेट कंक्रीट इन अर्थक्वेक प्रोन एरियाज, then there will be less chances of damaging of those structures. Is it okay?
Yes sir.
Any other question?
सर क्या हम लोग सेडिमेंट्री रॉक्स को कंक्रीट में यूज करते हैं?
इसमें अगर क्ले पार्टिकल्स बहुत ज़्यादा ना हो, क्ले कंटेंट बहुत ज़्यादा ना हो, so we can use this, but normally we will discuss the different type of tests which we are performing on the aggregates. So being a civil engineer, if you are not a civil engineer, or if you are not working on such projects, for example government projects where the specifications are not allowing to use such a type of materials, so for each and everything, if you are making your own house, then you are allowed, you can use this. But if the government rules are there, and they are looking for it, even if you are making your own house, so then you have to perform different types of tests, the soundness test, the abrasion test. So after that test, if it is in the range of the allowed specifications, then you can use it, otherwise you can't use this. Is it okay?
Okay sir, thank you.
जी, सैयद ज़ेगाम हाशमी, साद ज़ेगाम हाशमी, साद बेटा, साद ज़ेगाम हाशमी, are you in the class or you are reading for your CSS exam? माइक का मसला है साद का जो। ओके, तैमूर खान जदून, तैमूर खान जदून, तैमूर, उसामा शेर.
जी सर.
Okay, this Timur is absent. Usama Sher.
जी सर.
You are from
Mardan.
Mardan. So do you have any queries in the nearby area in Mardan for aggregates? क्रश कहाँ से मिलता है?
स्टॉक प्लेसेस है और क्यूरीज नहीं है.
कहाँ पे है? मर्दान में कहाँ पे है? ये काटलंग वाले साइड पे है?
जी सर.
हाँ? Okay.
काटलंग रोड पे.
Anyone from Lawrencepur or Nizampur? Anyone from Lawrencepur or Nizampur? Kala Dhaka? No? In every area, natural sources or natural resources are available for sand as well as for coarse aggregates. And normally in these hilly areas, the rocks are converted into crush, and then we can get the angular aggregates. Okay, so let's go to the next point or the next topic. Classification of aggregates according to size. इससे पहले कौन सा था? According to weight. तो आप लोगों ने इस हिसाब से याद करना है. Classification of aggregates according to weight, classification of aggregates according to size, classification of aggregates according to surface textures. But this is very, very important topic. Types of aggregates. We have fine aggregates and we have coarse aggregate. Do you remember what is
Yes,
fine
sir.
aggregate and what is coarse aggregate? क्या होता है?
Yes.
जी.
सर फाइन एग्रीगेट्स जो 4.75 मिलीमीटर सीप पे जो है वो पास करें और 75 माइक्रोन सीप को जो है वो उस पे रिटेन हो जाए और फिर
इसके साथ मैंने
कोर्स
आपको एक और
एग्रीगेट्स
भी
उन्हीं से
बताया
बने
था.
होते हैं.
इसके साथ मैंने बताया था सीव नंबर समथिंग.
सर 200
सर जो सीव नंबर 4 से पास हो और 200 पे रुक जाए वो फाइन होता है. जो 4 से पास ना हो वो कोर्स.
मोहम्मद सुहेब दोबारा बताए, ऊंची आवाज में बताए. मोहम्मद
सर
सुहेब.
जो सीव नंबर 4 से पास हो और सीव नंबर 200 पे रुक जाए वो फाइन होता है. और जो सीव नंबर 4 से पास ना हो वो कोर्स होता है.
Good, well done. So the aggregates which passes through 4.7 millimeters sieve are sieve number 4 and retain on 75 micron sieve or sieve number 200 are known as fine aggregate. याद रहेगा बेटा. ORR. The size of aggregates whose size is 4.75 or less are considered as fine aggregates. Now the size of fine aggregates ranges from 2.8 millimeter to 3.1 millimeter is coarse sand. If it is in this range, then we are calling it coarser sand. That the sand size is a better coarser. ठीक है बेटा. The size of fine aggregates ranges from 2.5 to 2.8 is called medium sand. It is in between the coarser one and the finer one. The size of fine aggregates ranges from 2.3 millimeter to 2.5 millimeter is known as fine sand. So further we can divide the fine aggregates into 3 different types on the basis of their particle size. The size of aggregates that are bigger than sieve number 4 are considered as coarse aggregate. इससे पहला कौन सा था? Fine aggregate. And now we are talking about the coarse aggregate. So if the particle size are bigger than 4.75 millimeter, then we are calling such type of material as coarse aggregate. Coarse aggregates is the basic materials of the concrete. Crushed stones or gravel used in concrete are known as coarse aggregate. Here you can see how we can classify the aggregates according to size. So these are the coarse aggregate. You can see this material and you can see this material. There are 2 types of material. So Arif Wazir, which one is better? This one or this one?
Sir ji, right side.
Right side. Why the right side one is better?
रेगुलर है.
Yeah, it have sharp edges. It will make a proper bond. It will make a proper interlocking inside the concrete. So it will give you more strength and will give you durable concrete. What about this one?
सर वर्केबिलिटी इसकी अच्छी होगी.
इसकी वर्केबिलिटी अच्छी होगी लेकिन इसका जो बॉन्ड स्ट्रेंथ है वो कम होगा. हाँ, इसकी जो
Yes, sir, इसकी
इंटरलॉकिंग है
strength
वो
decrease
कमजोर
होगी.
होगी. And it will not give you durable concrete. Okay. So gravel or shingle, this is also called shingle or gravel, and crushed stones having size greater than or equal to 5 millimeter, typically between 9.5 and 37.5 millimeter. Aggregates containing a whole range of particles are named as all-in or patron aggregates or well-graded aggregates. Is it okay? यहाँ तक ठीक है बेटा?
Yes.
Yes sir.
Any question? जी बेटा. Any question? Yes, no, yes, no.
No sir.
Okay, good. So let's talk about the factors which are contributing to the aggregate characteristics. So we have discussed the parent rock. We have discussed the parent rocks. From which rock you have got the aggregates? From igneous, metamorphic, or sedimentary rocks. Then prior exposure and processing factors. Either you have processed it, you have passed it from the crusher machine, or you are using it directly. It has got some exposure to the atmosphere or to the severe weathers, or no. Here you have just extracted it, and it have not been seen the weathering process. Okay, then we are talking about the microstructures. So in the microstructures, we are talking about the porosity, how much pores it has, what is the density of this aggregate, and mineralogical composition, what is the mineralogical composition of these rocks or this aggregates. Then we are talking in the mineralogical composition, we are interested in the crushing strength or the compressive strength, the abrasion resistance, how much it can resist the wear and tear, how much is the elastic modulus of this material, and how much is the soundness when you are passing it from the chemicals. We will discuss this in the soundness test. So how much resistance it gives you. Then the next one is the properties of the hardened concrete, how it helps you in the properties of the hardened concrete, how much ultimate strength it gives to you, abrasion resistance I told you, dimensional stability or the volumetric stability of the concrete, and finally how much durable the concrete is. Then the porosity, it is coupled with this one as well as with this one. So let's come from this side. The particles characteristics. What is about the size, about the shape and the textures. These are the very important characteristics or properties of the aggregates. So the properties of plastic concrete: uniformity or consistency, cohesiveness, and the unit weight. And then finally we have the concrete mix proportioning. Once we have all these things, then we can go to the mix design of the concrete, and then we can design the concrete according to the requirements of our project. Is it okay, beta?
Yes, sir.
Is it okay?
Yes, sir.
Okay. Important characteristics of aggregates toward making concrete include: number one, the bulk density and the specific gravity of the aggregate, the moisture absorption and bulking of sand, size, shape, and surface textures, and the index, that is the fineness modulus, impact, abrasion, and crushing resistance of the aggregates, the elastic modulus of the aggregates, and the soundness of the aggregates. So we will try to discuss them in detail. The gradation of the aggregates, as we discussed, this is the most important thing in the concrete. So grading is the particle size distribution of an aggregate is determined by a sieve analysis according to HTM C136 document. The grading and grading limits are usually expressed as the percentage of material passing through each sieve. You will see in the next slides. There are several reasons for specifying grading limits and nominal maximum aggregate size. They affect relative aggregate proportions as well as cement and water requirements, workability, economy, porosity, shrinkage, and durability of the concrete. So these are very important factors or characteristics of the aggregates. Variations in grading can seriously affect the uniformity of concrete from batch to batch. If you are not using the properly or the consistent grading of the materials, it can affect the uniformity or the consistency of the concrete. In general, aggregates that do not have a large deficiency or excess of any size and give a smooth grading curve will produce the more satisfactory results, or will give you the more satisfactory strength of the concrete and durability of the concrete. The cement paste requirements for concrete is related to the white content of the combined aggregates. If you remember, if you have more white, then you will need more cement paste, and it will make you the concrete uneconomical, and also the concrete will be not durable, and its strength will also decrease. The effect of a collection of various sizes in reducing the total volume of wires between aggregates is illustrated by simple method shown on next slide. How? Okay, anyone in the class who can help me in this? जी बेटा.
सर ये जो लास्ट में है ये सबसे ज़्यादा वेल ग्रेडेड है, और सर जो फर्स्ट में है उसमें सिर्फ कोर्स एग्रीगेट्स हैं, और जो सेकंड में है उसमें सिर्फ फाइन एग्रीगेट्स हैं, और इन दोनों में सीमेंट जो वॉल्यूम ऑफ वाइट्स हैं वो ज़्यादा हैं एज़ कम्पेयर टू सर जो थर्ड वाले हमारे पास बकेट है.
So which one is better, beta?
Sir, third वाली.
Last one.
Why the last one?
सर क्योंकि इसमें वेल ग्रेडेड है सब.
Okay.
इसमें whites कम है.
If this operation were repeated with several additional sizes, a further reduction in whites would occur. What is meant by this one? जी
अगर हम डिफरेंट साइज के एग्रीगेट्स यूज़ करें तो शायद के वाइड्स हमारे पास और कम हो जाए.
Exactly. Now we are just using two types of aggregates, or two sizes of the aggregates. Okay. Can you see over this? We have wires in over here. We have wires over here. But then when we are mixing them, then these smaller size particles, they are trying to cover these wires. But if we are further reduce the size of this one, or we add some other materials which have the intermediate size particles in between these two, it will further reduce the volume of wires inside this material. Okay, so when you have less wires in the concrete or less wires in the aggregates, then you can have a better quality of concrete. Note that when the beakers are filled with one particle size of equal volume, the volume of these two are the same. The white content is constant. You can see this is the white content, it is constant, regardless of the particle size. When the two aggregate sizes are combined, the white content is decreased. You can see the white content is decreasing. If this operation were repeated with several additional sizes, a further reduction in whites would occur. I hope it is now very, very clear. Is it okay?
Yes, sir.
Abdullah. Okay,
Yes, sir.
gradation of aggregates. G. The main factors governing the desired aggregate grading are: number one, the surface area of the aggregates, which determines the amount of water necessary to wet all the solids, and it will also disturb the workability, and it will also decide the workability of the aggregates, or sorry, the workability of the concrete. The relative volume occupied by the aggregates, how much volume has been occupied by the aggregate in the concrete. The workability of the mix, and the tendency to segregation. These are the main factors which are governing the desired aggregate grading. Now, gradation of aggregates, how we can perform the gradation. So the sieve analysis method is normally used. Particle size distribution is determined by sieve analysis method. Sieve analysis is the name of the operation of dividing a sample of aggregates into fractions, into small particles, each consisting of particles of the same size. In practice, each fraction contains particles between specific limits, these being the openings of the standard test sieves. Here you can see this is the coarse sieve, and this is the fine sieve. And this is the sieve shakers. You will have to keep the sieves in order. The larger size sieves on the top, followed by the smaller, and so on. But do you have this experiment in your lab course? The sieve analysis?
Yes, sir.
Yes, sir.
Mind the finance episode.
Okay, so is there any plan for your lab work? लैब वर्क आपका होता है कि नहीं होता है?
No sir, online है.
ऑनलाइन होता है?
Yes sir, online सर पढ़ा देते हैं, वीडियोस दिखा देते हैं.
अच्छा. Okay, so then I hope you remember this table. Have you people used this table in the sieve analysis process? This is the British standards. This is the sieve size in millimeters. This is the American standards, the sieve size in inches, then followed by the number. So why we are calling this sieve number 8? जी
सर इसके 1 इंच में 8 स्क्वायर होती है.
कौन से इंच? स्क्वायर इंच या
लीनियर इंच?
1 इंच स्क्वायर में सर.
लीनियर इंच में होता है. Okay, good. Okay, so when we are calling about sieve number 4, it means 4 wires or 4 holes in one linear inch. Do you know linear inch? जी, linear inch का पता है आप लोगों को? linear inch क्या होता है?
Yes sir, 1 इंच होता है.
जी जी
एक सीधा इंच होता है सर.
जी And then you can say the nominal openings in inches. This 3-inch sieve have the nominal opening size is 3 inches, 1.5, 0.75, 0.5, 0.25, 0.187, and here in millimeter is 4.75. So these are bookkeeping things. You just need to remember this sieve number 4 size, as it is the dividing line between the fine aggregate and coarse aggregate. This portion is representing the coarse aggregate, and this one is representing the fine aggregate. Okay.
सर
तो जी बेटा,
अरे सीव नंबर 200 से भी नीचे होते हैं सर?
जी बेटा बिल्कुल होता है। ये आप लोग you will read this in 4th semester in Soil Mechanics 1, and then we are performing the hydrometer analysis test. We are further dividing this clay in hydrometer analysis because we are needing such materials in dams, especially in earthen dams. Any other question, beta?
No sir, thank you sir.
Okay. So requirements of ASTM for fine aggregate grading, how we can do this. The fine aggregates must not have more than 45% retained between any two consecutive standard sieves. The fineness modulus must not be less than 2.3 nor more than 3.1. If this value is exceeded, the fine aggregate should be rejected unless suitable adjustments are made in proportion. You can add some other materials and then you can check its fineness modulus value of fine and coarse aggregate. How we can do this? The fineness modulus of either fine or coarse aggregates according to ASTM C125 is calculated by adding the cumulative percentages by mass or the cumulative percentages retained on each of a specified series of sieves, and then we are dividing the sum by 100. You can see the fineness modulus is equal to the summation of cumulative percentage retained on specified sieves whole divided by 100. You will see this in the next slide, how we can do this. The fineness modulus is an index or is a number of the fineness of an aggregate. The higher the fineness modulus, the coarser will be the aggregate. And the lower the fineness modulus, the finer will be the aggregate. Here you can see this, the sieve analysis method. Have you seen this table before? इस तरह का कोई टेबल आप लोगों ने बनाया है लैब वर्क में?
No sir.
नो सर। तो फिर क्या पढ़ते आप लोग लैब में बेटा?
सर ये हमने जब फाइनेंस को वो किया था तब इस टाइप का टेबल बना था।
हाँ ना, तो इस तरह का टेबल आप लोगों ने देखा होगा। So in column number 1 we have the sieve sizes. Here you can see 3 by 8 inch, sieve number 4, number 8, and sieve number 100. And finally we have the pan. Percentage of individual fraction retained by weight. इस पे कितना रिटेन हुआ है बेटा? 0%, 2, 13, 25, 15, 22, 20. How cumulative retained by weight? ये cumulative हम कैसे करते हैं? ये 0 कैसे आया है? ये 2 कैसा है? ये 15 कैसा है? How we got this 2, this 15, and this 40? Anyone in the class?
सर ऊपर वाले
मोहम्मद शोएब दोबारा बताएं बेटा।
सर जो ऊपर वाले सीन पे जो रिटेन हो जाता है हम उसको भी ऐड कर देते हैं।
ऊपर वाले सेव पे जो रिटेन होता है उसको हम ऐड करते हैं।
सर ये जो कम्युलेटिव परसेंटेज है इसको फिर हम लोग उसमें परसेंटेज ऑफ इंडिविजुअल फ्रैक्शन पे ऐड कर देते हैं।
ठीक है, तो
पिछले
0
वाले
को
के अगले वाले से।
मतलब ये और ये ऐड होगा तो ये 0 आ जाएगा।
नो सर,
एक ही रो
सर ये जो अब हमारे पास 13 है और वहाँ पर हमारे पास 15 आ रहा है, तो 13 में हमने वो पिछले वाले का 2 ऐड किया है।
अच्छा, this 13 plus 2 is 15 and this 25 plus 15 is 40. इस तरह आप कह रही हैं?
यस सर।
Are you
Yes,
sure?
sir.
आप ये कह रही थी कि 2 plus 0 is 2, 13 plus 2 is 15, 25 plus 13 is 40. इस तरह कह रही थी या जो मैं कह रहा हूँ?
यस सर, मैं इसी तरह से कह रही थी 15 plus 25 40, फिर 40 plus 15 55 इस तरह से।
अच्छा, आप इस तरह कह रही थी 13 plus 2 is 15, 25 plus 15 is 40, 15 plus 40 is 55, इस तरह?
यस सर।
Are you sure? नहीं, आप इस तरह नहीं कह रहे थे, आप इस तरह कह रही थी 2 plus 0 is 2, 13 plus 2 is 15, इस तरह कह रही थी आप।
सर दोनों तो सेम ही है।
सेम नहीं है ना, ये भी मेन क्वेश्चन है। ओके, यू आर रुकिया असद जी। सच
सर
बताएं,
फिर
सच बताएं।
सर कम्युलेटिव परसेंटेज को पहले ऐड करी थी और फिर दूसरे वाले को बाद में ऐड करी थी। कसम से सर।
जी नहीं, आप ये बताइए, बात आपने ठीक कही है। 2 + 0 is 2, okay?
Yes.
And 2 + 0 is also 2.
No,
2
no,
+
sir.
18 is 15. And 2 + 13 is
Yes.
also 15. तो आप इनको जमा कर रही थी या आप इनको
No,
जमा
sir.
कर रही थी? हाँ।
सर मैं ये कम्युलेटिव परसेंटेज को और इंडिविजुअल परसेंटेज को जमा कर रही थी।
अच्छा, इसको और इसको आप जमा कर रही थी?
Yes, sir.
Okay, what is your class number?
Class number 6.
Class number
6.
6. Engineer Malik Hamad beta, are you in the class? Malik Hamad. Okay, beta, remember, I will give you 2 sessional marks.
सर पॉजिटिव या नेगेटिव?
आरिफ वजीर आप बताइए।
Yes, sir. Positive.
Positive, okay, good.
थैंक यू सर।
Okay, so आपने फिर मैं नोट भी करता हूँ, आपने मुझे फिर रिमाइंड भी करना है, ठीक है? ओके, वेल डन बेटा। सो आप लोगों ने क्या करना है, यू हैव टू जस्ट add this value with this one, the previous one, okay, with this one. So you can see 15 plus 25 is 40, 40 plus 15 is 55, 55 plus 22 is 77, 77 plus 20 is 97. Is it okay? Now, why we don't have 100 over here, Arif Wazir? Why we have 97? जी आरिफ वजीर बेटा।
Sir, 77 plus 20 is 90.
Yeah, we have 97. Why we don't have 100 at the end?
Sir, pen जो 3 है उसको ऐड किया है।
Exactly, 3 is over here. 3 is here. Now let's calculate the percentage passing by weight. So 100 minus 0 is 100. 100 minus 2, 98. 100 minus 15, 85. 100 minus 40, 60. 100 minus 55, 45. 100 minus 77, 23. And 100 minus 97 is 3. Okay, so this is the percentage passing by weight from each seal. अभी आपको मैंने बताया था how we can calculate the finest modulus. You have to sum up all these values. Cumulative percentage retained by weight. So the sum of this is 286 divided by 100. Why we are dividing it by 100?
सर ये फार्मूले में गिवन था सर, ये परसेंटेज है इसलिए।
या सारे जवाब आप न देना, किसी और को भी चांस दिया करे so that they can get some sessional marks. जी Mazullah. Maz beta, are you in the class? Mazullah. Muhammad Danish.
जी सर।
जी, why we are dividing it by 100?
Sir, because we will find the percentage.
Because?
Sir, we find the percentage.
When we are finding the percentage, gentlemen, we are multiplying it by 100. जी मलक सूफिया। जी बेटा।
Yes, sir.
जी, why we are dividing it by 100?
So in order to get the percentage.
In order to get the percentage.
Yes, sir.
इससे
सर
पहले
परसेंटेज से निकालने के लिए सर।
Yeah, in order to remove the percentage, Muhammad Musa Jan. Good. In order to remove the percentage, we are dividing it by 100 because it is already in percentage. And we need a constant figure. We need one figure. So that's why we are dividing it by 100. So we are getting 2.86. Now, what was the range for the fine aggregate? Range किसी को याद है? किसी को याद है? 2.3 to 3.1. So it is in the range. 2.86. Okay. Now standard test sieves are as follows. For the coarse aggregate, we are using this number sieve having size 3 inch, followed by 38, 20, and 10 millimeter. For the fine aggregates, we are placing the sieves in this order. sieve number 4, sieve number 8, and so on. The finest modulus limits for the fine aggregates is in between 2.3 to 3.1. For coarse aggregate, it is in between 5.5 to 8. And for combined aggregates, when we have the coarse aggregate as well as the fine aggregates, then this range varies from 4 to 7. Now, types of gradations. I hope you remember we have already discussed. The gap grading is a grading in which one or more intermediate size particles are omitted. In gap grading, one of the particle size is not available. Well graded means sizes within the entire range are in approximately equal amounts. Friction at many points in between the particles, excellent interlocking between the particles, and very few voids in between the particles. Uniform gradation means a large percentage of the particles are approximately the same size, which have uniform size. So when you have this uniform gradation, then you will be having poor interlocking. The high percentage of voids will be there, and the friction at few points of contact. So there will be no friction at many points. So you will not have a proper concrete or proper bonding. Combined gradation means fine and coarse aggregates are combined. Then we will have friction at many points. There will be good interlocking. There will be very few wires, and it will be economical. So always go for well-graded aggregates or well-graded materials. Now coming towards the particle shape and surface textures. We have already discussed this in the previous lecture. The shape, angularity, and surface textures of the individual particles of aggregate have an important influence on the workability of freshly mixed concrete and the strength of hardened concrete as well. If you remember from the properties of the fresh concrete and the properties of the hardened concrete, we have discussed this. Shape refers to
Yes, sir.
geometrical characteristics such as rounded aggregates, angular aggregates, elongated aggregates, or flaky aggregates. Now, what are rounded shape aggregates? Rounded shape aggregates are naturally occurring aggregates. It is fully water worn because the water is passing through it continuously, and they are trying to cover or to warn it or to due to this abrasion or this wear and tear process, it becomes rounded, are completely shaped by the abrasion process. For example, river or seashore gravels, desert and wind-blown sand. When the air is also passing, or when these particles are coming in contact with each other, then at surfaces or the angularity of these particles is uh, decreasing and it becoming smooth particles. Now, irregular or partly rounded shape aggregates. Naturally, irregular are partly shaped by abrasion and having rounded edges. For example, hard gray siliceous stones. Angular shaped aggregates, ये कौन से होते बेटा? It possess well-defined edges, formed at the intersection of roughly planar surfaces. These are obtained by crushing the rocks, for example, crushed rocks of all types. Then we have flaky aggregates. If you remember, I explained this in the previous lecture, that flaky aggregates are those materials of which the thickness is smaller as compared to the width and length of that aggregate. For example, laminated rocks, both naturally occurring as well as crushed. Then we have flaky and elongated aggregates, those materials having the length considerably larger than the width and the width considerably larger than the thickness are known as flaky and elongated aggregates. Now coming towards the surface textures of the aggregates. Surface texture is a measure of relative degree to which particle is polished or dull. Smooth bond between the cement paste and aggregate will be weak if you are using this smooth aggregates. When you are using this rough aggregates, bond between the cement paste and the aggregate is strong. Rough texture has better bond and tension as well as in compression. Importance of particle shape and surface textures. The particle shape and surface textures of an aggregate influence the properties of freshly mixed concrete more than the properties of hardened concrete. Roughly textured, angular, elongated particles increases the void between aggregates particles than do by the smooth aggregates and rounded aggregates. The rough textures, angular and elongated particles increase the voids between aggregate particles than do by smooth and rounded aggregates. The mixing water and cement requirements tend to increase as aggregates void content increases. Do you remember the smooth aggregates and rounded aggregates will need less water and it will give you high workability? याद है बेटा आप लोगों को?
Yes, sir.
Yes, sir.
And this rough textures, angular and elongated particles, as the surface area is increasing, so it will need more water and ultimately it will give you less workability if you are using the same water content for the smooth and rounded aggregates as well as for the angular and elongated particles. Hence, aggregate particles that are angular requires more cement to maintain the same water cement ratio. याद रहेगा बेटा ये? याद रहेगा?
Yes, sir.
Yes,
The
sir.
bond between cement paste and a given aggregate generally increases as particles change from smooth and rounded to rough and angular aggregates. We have discussed this many times. This increase in the bond is a consideration in selecting aggregates for concrete where flexure strength is important or where high compressive strength is required. A rougher texture results in a larger adhesive force between the particles and the cement matrix, resulting in a better aggregate cement bond. So always better try to use the rougher texture aggregates or the rough aggregates on the angular aggregates. Is it okay? Try to avoid these smooth and rounded shape aggregates. Now coming towards the bulk density or unit weight of the aggregates. The bulk density or unit weight of an aggregate is the mass or weight of the aggregates required to fill a container of a specified unit volume. The term bulk is used since the volume is occupied by both aggregates and voids. As I told you in the previous slides, that bulk means we are taking the volume of the aggregates as well as the volume of voids in the aggregate. The approximate bulk density of aggregates commonly used in normal weight concrete ranges from about 1200 to 1750 kilogram per cubic meter or 75 to 110 pound per cubic feet. Methods of determining the bulk density of aggregates and void content are given in scheme C29 or American Association of State Highway and Transportation Officials T19 document, useful to classify between light and heavy weight aggregates, converting proportions by weight to proportions by volume. So I hope you have this in the complete lab course, but if it is not here, then you will have this in the fourth semester in the Soil Mechanics 1 lab course, and you will have to perform this over there in the soil mechanics lab. Now the bulk density or unit weight. Anyone in the class who can help me in explaining this slide? Ji beta.
Yes, sir.
You want to help me? Ji.
Yes.
जी मोहम्मद जीशान.
सर बल्क डेंसिटी जो होती है सर उसमें हमारे पास जो होते हैं सर मास पर यूनिट वॉल्यूम जो होता है, वेट पर यूनिट वॉल्यूम जो होता है उसको हम बल्क डेंसिटी कहते हैं सर. और ये जो होता है सर हमारे पास लोअर वेट जो होती है उसकी बल्क डेंसिटी भी कम होती है क्योंकि उसमें पोर्स ज़्यादा होते हैं. पोर्स ज़्यादा होने की वजह से सर जो एग्रीगेट्स है वो कम एरिया पे होते हैं और मतलब ज़्यादा एरिया पोर्स ने घेरा हो तो इसलिए उसकी बल्क डेंसिटी कम होती है. जबकि इसके बरक्स जो हमारे पास हायर बल्क डेंसिटी है सर उसकी वेट हायर होती है क्योंकि उसमें पोर्स कम होते हैं और मोर स्पेस पे हमारे पास एग्रीगेट्स है उसने स्पेसिफाई वो घेरा हुआ होता है सर, तो इस वजह से उसकी बल्क डेंसिटी भी बड़ी ज़्यादा होती है सर.
Okay, what is your class number?
25.
Mohammed Zishan, 25. You will get 0.5 session marks.
Thank
okay,
you,
you
sir.
are right. Here you can see beta. Lower the bulk density means lower the weight. Lower the weight means more are the pore spaces inside this volume. So you can compare these two. Here you can see higher the bulk density means higher is the weight because more of the spaces has been occupied by the materials. There are less wires and less pore spaces inside this aggregate. So the main thing in which we are interested, we have to avoid the wires or the pores in the concrete. Is it okay? Is it okay? Bulk density or unit weight. The void content between particles affects the paste requirements in the mix design. Most natural aggregates have particle densities of between 2400 and 2900 kilogram per cubic meter or 150 and 181 pounds per cubic feet. Now coming towards the specific gravity, the relative density is called specific gravity of an aggregate is the ratio of its mass to the mass of an equal volume or equal absolute volume of water. It is used in certain computations for mixtures proportioning and control, such as the volume occupied by the aggregates and the absolute volume method of mix design. When we will discuss the mix design topic, you will see how the specific gravity is important. Most natural aggregates have relative densities between 2.4 and 2.9. Test method for determining the relative density for coarse and fine aggregates are described in HTM C129 and ASHTO or ASHTO T85 document, in HTM C128 and ASHTO or ASHTO T84 respectively. So if you are interested to read more about this specific gravity, you can read these documents. Density, mass per unit volume is called density. An approximate value of 1000 kilogram per cubic meter or 62.4 pound per cubic feet. I hope you remember this, 62.4 pound per cubic feet or 1000 kilogram per cubic meter is often used for the density of water. Most natural aggregates have particle densities in between 2400 and 2900. ये जो previous slide पे भी आप लोगों ने देखा इसको. Okay, assignment number 3. Assignment number 3 में आप लोगों ने क्या करना है बेटा? Number 1. You have to define and explain the impact, abrasion, and crushing resistance of the aggregates. You have to define and explain the elastic modulus of the aggregates. बेटा आप लोग इसको पढ़ ले, आपके काम आएगा. पहले इसको पढ़ ले, उसके बाद असाइनमेंट अटेम्प्ट करें. ठीक है, कॉपी पेस्ट न करें किताब से. Define and explain soundness test of the aggregates. Define and explain the bulking of sand. This is very, very important, the bulking of sand, and also the soundness test. Okay, so should we continue या थोड़ा सा ब्रेक ले ले बेटा? आरिफ अब्दुल्ला, आरिफ वजीर,
काफी टाइम हो गया सर, ब्रेक ले लेते हैं छोटा सा सर.
Okay, let's say 10 minutes is okay.
15 minutes sir.
Yes sir.
जी, Haris, you want to have 5 minutes? Beta, are you in the class?
वालेकुम सलाम.
Yes sir.
ठीक है बेटा, कंटिन्यू कर ले बेटा.
Yes sir.
Okay बेटा.
Yes, sir.
Okay.
Yes sir.
Thank you. So now let's talk about the absorption and surplus moisture of the aggregates. The absorption and surplus moisture of the aggregates should be determined according to HTM C70, C127, C128, and C566 documents, so that the total water content of the concrete can be controlled and correct batch weights can be determined as per the requirements. What is meant by this? Ji. Let me ask Ruqayya Asad.
Yes sir.
जी, इसका क्या मतलब है?
सर किसका?
ये जो अभी आप कहाँ थी अभी तक?
सर मैंने अभी ज्वाइन किया.
खुर्शीद अहमद. खुर्शीद अहमद.
जी सर.
जी, आप बता सकते हैं बेटा?
आवाज कट रही है सर. सवाल
बेटा आप बता सकते हैं इसका क्या मतलब है?
एब्जॉर्प्शन का सर.
जी, वाटर एब्जॉर्प्शन. अगर एग्रीगेट्स में वाटर एब्जॉर्प्शन हो तो व्हाट वी नीड टू डू, the aggregates which we are using in the concrete, as it has already absorbed some water, or if there is some water on the surface of this aggregates, so how it will affect the concrete workability, the concrete strength, and the concrete durability. जी बेटा.
सर
सबर करे बेटा. जी खुर्शीद बेटा.
सर अगर ये एक्सेस में होगा तो सर इसकी अगर वाटर एक्सेस में होगा तो सेग्रीगेशन वगैरह होगी सर. और सर लेस होगा तो सर ये हार्डन हो जाएगा.
जी ये कौन थी? रुकैया से मैंने पूछा था.
यस सर. सर ये जो आपने हमें बताया था कि जब हम लोग कंक्रीट बना रहे होते हैं तो उसमें वाटर सीमेंट रेशियो हम इस तरह से रखते हैं कि फिर उसमें जब ये एग्रीगेट्स का जो वाटर जो हमारे पास है एग्रीगेट्स वाटर रिलीज करना है उसका भी आ जाए. तो सर फिर हम लोग इस चीज़ का ध्यान रखेंगे.
कैसे?
सर एज डिफरेंट टाइप्स ऑफ टेस्ट परफॉर्म करके.
फॉर एग्जांपल जी आरिफ वजीर.
ये सर अगर एग्रीगेट के साथ पानी है तो फिर हम बेचिंग प्राइस में जब मेजरमेंट करते हैं पानी तो कम इसमें डालते हैं क्योंकि फिर ये ब्लीडिंग इस सबब बनते हैं।
बात आपकी भी ठीक है, बात रुकैया की भी ठीक है, लेकिन कैसे? लाइबा सब्र करो जी। आरिफ वजीर बेटा।
सर जी तो ये हम इस तरह कंट्रोल कर सकते हैं बेचिंग प्रोसेसिंग सर, जब हम
कैसे
इसके
कैसे
इंग्रेडिएंट्स में
तरीका
डालते
बताओ, तरीका बताओ।
हैं सर हम कम वाटर डालते हैं इसकी
किस हिसाब से करेंगे? कम
मेजरमेंट।
वाटर डालेंगे, लेकिन किस हिसाब से करेंगे? हाउ यू विल मेजर दिस?
सर जी
बेटा।
सर इसका पता नहीं सर।
हाँ जी लाइबा।
सर ये एडमिक्सचर यूज करेंगे उससे स्लम्प को कम
खुदा के
रखेंगे।
बंदे लाइव इंटरवेंशन की जरूरत क्या है अभी? We are just talking about the excess water quantity and the aggregates.
सर
Anyone in the
स्लम्प
class? जी बेटा, anyone in the class? जी उसामा शेर जी बताओ, शाबाश।
सर मिक्स डिजाइन प्रोपोर्शनल के जरिए।
या मिक्स डिजाइन में तो हम इसको डील करेंगे, लेकिन कैसे करेंगे ये बताओ। मैं वो जो मेन चीज है वो सुनना चाहता हूँ।
सर मॉइस्चर कंडीशंस को सामने रखकर उसके अकॉर्डिंग चलेंगे।
जी anyone in the class? I will give her 2 sessional marks. मोहम्मद सोहेल।
क्या हम वाटर सीवेज रेशो को आप तैयार करेंगे? जितना हम सीवेज लेट करें वो सब वाटर के साथ एक करके उसको यूज
ये
करेंगे।
तंजीला मुराद। देखिए बेटा, ये इस स्लाइड को मैंने चेंज भी नहीं किया था। each and everything is available here. The amount of water added at the concrete batch plant must be adjusted. How? For the moisture conditions of the aggregates in order to accurately meet the water requirement of the mix design. इसके ऊपर या इसमें जो ऑलरेडी वाटर मौजूद है, आप क्या करें, आप एक स्मॉल सैंपल इससे ले लें, उसको ओवन में टेस्ट करें और इसकी जो वाटर कंटेंट है, वाटर एब्जॉर्प्शन, इसमें जो वाटर ऑलरेडी मौजूद है वो आप कैलकुलेट करें कि हाउ मच वाटर इट हैज बीन एब्जॉर्ब्ड. Okay beta, so the water which will be required in the water cement ratio to lubricate these surfaces, अगर इसके surface पे पहले से पानी मौजूद है, so that will get evaporate and you will get the quantity of that water. So when you are making the concrete, you can deduct, you can subtract from the total quantity of water this quantity of the aggregate which is available on the aggregate surface, because you cannot dry the whole aggregate, the big volume of the aggregates you can't dry it, you can't put it in the oven. So how we can adjust the volume of the water? You just to reduce or you just to subtract the quantity of water which the size of these particles have been on its surface. Is it okay? अब देखिए स्टेट है आपके पास ओवन ड्राई, so there is no moisture, there is no water. Now it is air dry, so we have no water on the surfaces, and the top surface is also dry. We have less than potential absorption. The potential absorption is this total. Now saturated surface dry, you can see this is completely saturated inside, but the surface is dry, so it has equal to potential absorption. This much potential it has to absorb the water. The next one is the damped or the wet material. It is greater than the absorption. This was the absorption capacity inside the line, but on the top of the line, this is the extra. This is the damp or the wet on the top of the aggregate particles. So what is oven dry condition? All the evaporable water has been driven up by heating the aggregates to around 100 degrees C. This is called oven dry condition. Now air dry condition, dry at the particle surface but containing some interior moisture, thus still somewhat absorbent. Here you have already seen this one. It has some absorption. Then saturated surface dry condition. This is also called SSD condition. आप जुबानी याद रखें इसको, ये आपके काम आएगा. When all the permeable pores are full and there is no water film on the surface. There is no water film on the surface, but the inside of the pores are filled with water. So this is called surface saturated dry. wet or damp condition, when the aggregate is saturated and there is also free moisture on the top of the surface, then it is called wet or damp condition of the aggregate. Now, what is absorption capacity of the aggregates? Absorption capacity of the aggregates can be defined as the total amount of moisture required to bring an aggregate from the oven dry condition to the surface saturated dry condition. From which condition to which condition? From this condition to this condition. The moisture required to bring the state of the material from this condition to this condition is known as, क्या कहते हैं इसको बेटा? Absorption capacity. Now, what is effective absorption? Effective absorption is defined as the amount of moisture required to bring an aggregate from the air dry condition to the surface saturated dry condition. From this one to this one. This is called effective absorption. Now, surface moisture क्या होता है बेटा? Surface moisture is the amount of water in excess of the water required for the surface saturated dry condition. This one, the extra one. Now, the next one, the absorption capacity, effective absorption, and surface moisture data are invariably needed for correcting the batch water and aggregate proportions and concrete mixtures. So when we will discuss the design of the mixed design of the concrete, there you will learn how we can subtract this extra amount of water from the water cement ratio. ये आप याद रखें. You will use this. Once we calculate the weight of this water or the volume of this water, then we can subtract it from the total amount of water required for the water cement ratio or required for the concrete mixing. याद रहेगा बेटा? याद रहेगा आरिफ वजीर?
Yes sir. Yes sir.
सोहेब, हारिस अब्दुल्ला,
Yes, sir. Yes,
मोहम्मद
sir.
तैयब, मोहम्मद जीशान.
Yes, sir.
सबको याद रहेगा इंशाल्लाह.
Yes, sir.
ठीक है बेटा. Next topic is bulking of sand. This is very simple. I have shared some links for a video from YouTube. You can see that, and once you come to the department, you can perform this experiment in the lab as well. Bulking of sand is very important. इसको आप पढ़ लें. If you have any problem, we can discuss in the coming class. Then resistance to freeze and thaw, we have already discussed this in the admixture topic. Resistance to freeze and thaw is continuous. Abrasion resistance, also I have added a link for this test in your classroom. आप उसको जरा देख ले. You will learn how this test is performed and what is the importance of this test. And then the soundness of aggregate, also I have shared a link for this test. So this is also very important test. आप वहाँ पे कोशिश करें. You will learn this. If you can't learn this, you can ask me in the next class. In 5th semester or 4th or 6th semester, you have this test as well in the soundness of aggregate. This you will learn this in the transportation course, because the aggregates are used in the road construction. So there we are normally performing the soundness test on the aggregate as well. याद रहेगा बेटा? Is it okay?
Yes,
Are
sir.
Yes sir.
Yes, sir.
Is it okay?
Yes, sir.
Now, if you have any question,
Yes,
you can
sir.
ask. जी Haris. No question. जी.
सर एग्रीगेट्स में फ्रिक्शन डिजायरेबल है.
एग्रीगेट्स में फ्रिक्शन डिजायरेबल है. जी बेटा, जितना फ्रिक्शन ज्यादा होगा उतना आपका जो स्ट्रेंथ है, उसकी जो इंटरलॉकिंग प्रॉपर्टीज है वो बेटर होगी. फ्रिक्शन नहीं होगा तो आपकी जो दैट्स व्हाई वी आर डिस्करेजिंग द यूज ऑफ स्मूथ मटेरियल, जहाँ पे फ्रिक्शन बहुत कम होता है या बिल्कुल नहीं होता है. उसामा शेर, गुड. एनीवन एल्स? Muhammad Rizwan. Muhammad Rizwan, you have never talked in the class. Muhammad Rizwan. Who are you? Muhammad Rizwan. Muhammad Rizwan, can you talk?
Yes, sir.
बातें कर सकते हो?
Yes, sir.
जी. You have never asked a question. You have never answered a question. You have never participated in the class.
Question नहीं होता sir.
Why बेटा? जी. नेमतुल्लाह ने भी क्लास छोड़ दिया. वो भी सोच रहा था किस तरह का क्वेश्चन आएगा. Okay बेटा, this is just on a lighter note. If you have any question, you can ask. Otherwise, let me stop the recording, beta. And
सर
then
ये जो हम लोग एग्रीगेट्स में वो कंक्रीट में एग्रीगेट्स यूज़ करते हैं इनमें कौन से वाला बेस्ट है मतलब जिसके अंदर कितनी वाटर कंटेंट हो
बेस्ट इज वो है जिसमें कोई भी वाटर कंटेंट ना हो, जीरो वाटर कंटेंट। फिर आपको आसानी होती है उधर कैलकुलेशन में, हम देख लेंगे। then we will be discussing this next design topic। तो जहाँ पे पानी नहीं होता है वहाँ पे आपकी कैलकुलेशन भी आसान हो जाती है और वहाँ पे आपकी मिक्सिंग और बाकी जो कंक्रीट बनाने का जो प्रोसेस है वो भी आसान हो जाता है।
और सर एक बार जब वाटर निकल जाता है एग्रीगेट से तो इसके बाद वो दोबारा वाटर को एब्जॉर्ब करते हैं?
बेटा बारिश हो जाती है, तो ये क्या कहते हैं उसको, डीव पड़
तो
सकती
फिर
है, वो
तो
पानी
सर कंक्रीट से भी वो लोग वाटर
जी
दे सकते हैं?
बेटा।
कंक्रीट से भी तो फिर सर हम लोग जो वाटर ऐड किया होता है वो उसमें फिर
बेटा एक दफा हम
मतलब
कंक्रीट में इसको
एग्रीगेट।
इस्तेमाल करें फिर वी हैव नो टेंशन। ये कंक्रीट बनाने से पहले की बात कर रहा हूँ।
ओके
ठीक
सर,
है,
थैंक यू।
ओके, एनी अदर क्वेश्चन? लेट मी स्टॉप द रिकॉर्डिंग बेटा।